Okay guys, so this is just a little intro to magnetic fields and forces. So just a quick intro and then you can do a couple practice problems just to get into this stuff. So, magnetic fields. Just as each charge will produce electric fields, each magnet creates its own magnetic field. Magnetic fields are also vectors, okay, very important. So they have a specific direction, so we need to keep that in mind. The direction of the magnetic field is defined by the direction the north end of a compass needle points when it is placed inside that magnetic field. So wherever north of compass points. Okay, so say here, if we're looking at a magnetic bar here, if say a compass was placed here, it would be pointing north. Okay, so that's why we have our arrow going this way. If it's placed here, it'd point this way because it'd be pointing towards the north. Okay, here it's pointing towards the north. Now, when we think about Earth here, the planet is like a bar magnet. So it's like here, okay, if we had our bar, it would be, this is the south magnetic pole, and here's the north magnetic pole. So it's flipped in terms of geographic poles, okay? So in conclusion, magnetic fields always point out of north and always point into south. So always out of north and always into south. Recall that opposite charges attract and similar charges repel. So we can apply this as well to magnets. And you know what that's like. You know when you bring magnets close together that are the same ends, that you can feel that force. You can feel how they're repelling each other away. These interactions could be explained by electric field lines. The same is true for magnetic poles. Like poles repel, i.e. north versus north or south versus south, and unlike poles attract, so north and south. So take a look at our arrows here. They look very similar to when we did our electric fields. So when we have a north and north between each other, or facing each other, their magnetic fields push out, and there's no field, or there's no field strength in the middle. Okay, same with south and south. But when north and south are put together, the field lines actually converge. Okay, so we have they converge here and basically create that strong pull coming in. So when we summarize our different fields, we've looked at gravitational, Physics 20. We've looked at electrical, the first part of this unit, and then we did magnetic, or we're doing magnetic. So when we think about a source here, when we did gravitational field strength, we measured the masses, okay? So what's the weight of our source? And in our equations, that's what we would put in, like the mass of the planet, or the mass of us, if we're experiencing the planet's gravitational pull. The direction goes towards mass only, the mass that's producing, okay? So Earth's gravitational field is always pulling towards Earth, okay? And that's the only direction that it goes. Electrical fields, the source is a charge, okay, or charges. And this is always, it goes away for positive, or toward for negative charges. That's kind of our rule that we use there. And then for magnets, the source is the magnet itself, the object. And it always goes away for north, or we could say it goes towards
or south, the magnetic pole. So that's it for your introduction. You can do questions 1 to 6 now in your workbooks. I'll provide the answer key, so take some time to go through those and see how you do.